Speaker is Kerry Sloan, using double machine learning to estimate Cartel.
Okay, hi, I'm Kerry. So I work for Frontier Economics, and I did this work with my colleague Anna. And for a bit of context, we mainly work in court cases, so like litigation cases, breaches in competition law, and we often inform expert witness reports. So a cartel, in an economic sense, most people think drug cartels, in an economic sense, what it is a group of firms who collude to raise prices, and this has some harm on the consumers as a result. And what we do is we come into the court and we say, like, okay, what's that damage? So how much do we owe to the consumers as a result of this cartel that has been caught? So much less exciting than drugs, I've taken a dairy cartel. So we have the Milk and Cheese Initiative. In 2011, our regulator, the Competitions and Market Authority, found 3 infringements essentially by our supermarkets. So we have like our classics, Asda, Tesco, Sainsbury's. Essentially, they shared information about their pricing strategies. That's a problem because if you know how other people are going to price, that means that you can price like that. There's no competition. So if someone else raises prices, what we would expect is that consumers substitute to the lower price. So the consumer has a choice. What actually happens is if you share your pricing incentives, everyone raises them at the same time and there's harm to the consumer. And like most of our work is confidential, so I've had to kind of take a little bit of a dummy data set here, as in this is real data, but the reason I could use this is because actually the Competition and Market Authority in this case had such strong evidence that it happened that they didn't do any econometrics. So essentially they found documents that said, we plan to raise our price of milk by 2 pence per litre. So what we would have done though, if we had come into this case, typically is do something like this. So you have a panel data set, and what you're interested in is a cartel dummy. So when the cartel period existed, you have a bunch of controls and you have some index of price. Your coefficient on your cartel is your effect of the cartel. But we have a lot of issues doing this with linear regressions like this. Namely, a lot of our covariates, we have to make choices. They're really highly correlated. Think of all the ways you could control for demand, all the ways you could control for supply. And what you pick, often we call it p-hacking. You get what you want based off of what you pick. So we thought, why don't we try using double machine learning? We have not successfully brought this into a court case yet, but we're getting very, very close. So a quick introduction on double machine learning. I'm sure most of you know, so I'm going to be really quick on this. But essentially, if you have this equation at the top and you want to estimate price, you've got a dummy for your cartel, and you have some G of X, your controls. The reason we can't typically use machine learning methods in this setting is that machine learning methods introduce some level of bias in the aid of prediction. They are made to predict, right? Let's take a lasso, for example. It looks in all senses to an untrained eye like an OLS. What you're actually doing is you're shrinking those coefficients down towards 0 to aid prediction. So you're in sample, you fit the line less well, so out of sample you do better, right? But you can't do that. We can't shrink down, let's shrink the effect of this cartel and say that they actually didn't have such a big impact on price. That's obviously problematic for us. So double machine learning, this new method, what we do is it's 2 stages. First of all, you predict your treatment and you predict your Y. You take the residuals of that. So sorry, when you do that prediction, you're using the controls. So those residuals, hopefully intuitively, are the part of your cartel and the part of your price that are unexplained by your co-founders, your covariates. You take those residuals and you regress them on each other and you have your cartel coefficient, right? This, if you do it with OLS, the first stage is exactly the same. You get the same coefficient as if you just controlled for everything in OLS. But the neat bit of this is that this paper proved that if you do the first stage with machine learners, as long as that prediction is good enough, you can still get an unbiased coefficient in your second phase. So we did it with this dummy milk and cheese cartel. And I want to take a look, first of all, at the first 2 rows, because they're kind of obvious ones. We have an OLS regression where we introduce our usual stuff that we would do. So we have demand, supply, costs. I had to control for mad cow disease, so shocks like this. And we have this is an index. So basically we have a 5% increase in price, and it's significant. We do the same thing with Lasso, but I threw in way more things that I think are relevant. So I let it pick between a lot of correlated variables. I introduced measures of economic health, and I over tripled the number of variables I'd throw in, and I'd overfit my OLS doing this, and I get a really, really, really similar result. What was actually super interesting about this work, though, wasn't this specific 2 rows, but it's the last row that I really like. And the last row, What we're seeing here is a lack of common support. So what I want you to do is look at the last two columns. The last column over is the root mean squared error of my prediction on treatment. So this is how well I can predict treatment. You can basically see that it's 0, right? I predicted treatment. This is the error. I predicted treatment almost perfectly. This is a typical propensity score problem, right? I have a lack of common support. So what this means is key covariates to explain my price only exist at that level during the period where the cartel existed. Now, this is the nature of time series data in economics cases like this, right? I have a trending demand variable, I have a trending measure of economic health. And that means that my machine learner that isn't bound by a functional form like Lasso, so my tree-based method is highly nonlinear. So what it can do is it can split out the data really, really well and say, okay, when demand is between A and B, this is my cartel period. If you remember, it's a two-stage regression, so if I perfectly predict in my first stage, I have no residual variation to exploit in my second stage, and I'm getting a 600% increase in price, which we obviously did not see in our price of milk in 2002. So what does this mean? Well, first of all, it doesn't mean that it's wrong to use OLS methods, because a lot of economists take that away. Fitting a functional form is fine. It's a fair enough way to extrapolate into a space where we don't have data. We have to do something in these cartel cases. It also means that Lasso is quite neat here for helping with some variable selection. I can still use that. What it really means is that if I have some cyclical data, or I demean my data, or I do something to make the data look more cyclical, and this is kind of an extension we want to look at, is a different case potentially where we don't have this lack of common support. The benefits of using random forests and DML could be really unprecedented in this case, and we've been pushing quite hard as a firm to try and get into active court cases now the use of double machine learning.
Court case to accept that DML.
I mean, there's a lot of issues, and so, I mean, mainly we work with lawyers who don't have have no economic background, never mind statistical. So it's difficult in the first place to get people to just accept economic evidence and econometric evidence as it is. And like even this method with the OLS, like this isn't even taking into account, right, like the feedback loops that were talked about earlier, right? So some cases, if you have a judge or an expert witness who's really willing to push the econometrics, you can start to introduce things like dynamic panels and things that are even more complicated just on top of an OLS. So DML is one of these cases where that's even more complicated and it's viewed as very black box, and a lot of people push back from it because they don't think that the judge is going to understand who makes the decision. So really, I think if I'm perfectly honest, what will get it there is when the client, it drastically improves their results. So they push for it enough that that we get what we want.
Understanding incentive. All right. Thank you again.